Hello my dear students, I welcome you all to SVK tutorials. So in this session I am continuing with model question paper 1 with effect from 2021 for the second semester. The subject name is Advanced Calculus and Numerical Methods. Subject code is 21MAT21. So I am continuing with module 2 in this session. So module 2 is of vector calculus. So you are going to have vector calculus means vector differentiation and vector integration you are going to have. So here you can go through the model question paper of module 2 is question number 3a and 4a will be of module 2. Vector differentiation, vector integration will be there. So in that question number 3a is as follows: find the directional derivative. Find the directional derivative. You are required to find out directional derivative of the given scalar function. Phi is always called as scalar function at the point 1, minus 2, 1 in the direction, along the direction of the vector 2i minus j minus 2k along the vector. So consider how to solve this. We are required to find out finally the directional derivative is given by the formula called del phi dot n cap. Del phi dot n cap. This is what the formula for directional derivative. So first let us define the scalar function as phi. Here I have considered phi equal to x square yz plus 4xz square. So then find out grad phi, that is nothing but del phi. Del phi you are going to find out. Del phi is defined as del phi by del xi plus del phi by del yj plus del phi by del zk. It means that you are going to differentiate this phi function with respect to x, partially treating x, y and z as constant. Differentiate phi with respect to y, treating x and z as constant. Differentiate phi partially with respect to z, treating x and y as constant. So here I have the solution. Del phi by del x is given by derivative of x square yz with respect to x partially. It is given by yz is constant here. Yz will be treated as constant. Derivative of x to x square is 2x. 2xyz plus derivative of 4xz square with respect to x is 4z square. I plus del phi with respect to y. Wherever you have the term called y, you can differentiate that term. The rest of the term will be 0. Sum. I am talking about sum. So here x square yz. Here in this term we have y. Differentiate y with respect to y. It is 1. So you are left out with x square z plus in this term there is no term called y. So therefore it will be 0. Derivative of any constant is 0. So you are left out with x square z. That is what del phi by del y. Similarly, next if you consider x square partial derivative of phi with respect to z. So you should differentiate phi partially with respect to z, treating x, y as constant. Here we have the term called z. Derivative of z with respect to z is 1. You are left out with x square y. That is what I have written, x square y plus derivative of 4x z square. Derivative of z square is 2z. So 2 into 4 is 8xz. That is what I have written. So now as in the given question, find the directional derivative at the given point. They have given the point here. You should substitute that point. I am substituting that point here at x, y, z. The points represents x, y, z value. Just put x equal to 1, y equal to minus 2, z equal to 1. So when you substitute that, the first value becomes 0i plus j plus 6k. This is what I have got del phi at the given point. So it depends on the point. So then I am going to find out n cap. N cap is given n cap is given by, consider any vector. Here I will define this given vector as vector a divided by magnitude of that vector. Magnitude of that vector. We require to find out n cap as what? Given vector divided by magnitude of that vector. So here given vector is 2i minus j minus 2k divided by magnitude means square root of sums of coefficients of I, j, k. What is magnitude of A? It is squares of sums of coefficients of I, j, k. So therefore it is 2 square, it is 4 plus minus 1 square, it is plus 1 plus minus 2 square, it will be plus 4. So simplifying this, we are going to get 2i minus j minus 2k divided by 3. That is what n cap. So then directional derivative is given by del phi dot n cap. Just substitute the value del phi and n cap. Go with dot product. You should know the dot product meaning. If you consider ai plus bj, I am considering only 2 dot ci plus dj is nothing but multiplying the coefficients of I, that is a, c plus b, d. This is what dot product. Just multiply the coefficients of I, j, k here. So that is what dot product. Here we have del phi dot n cap. So when I multiply, n cap is given by 2 by 3 minus 1 by 3 minus 2 by 3. So 0 into 2 plus 1 into minus 1. This is what I have written here. 0 into 2, 1 into minus 1 plus minus. Here you can make a correction here. It is plus 6. This is what? It is plus 6. 6 into minus 2. 6 into minus 2 is nothing but we are going to simplify further. So it is nothing but we are left out with what? Minus 1 minus 12. So which is nothing but all divided by 3, which is this. We are going to get the value as what? Minus 13 by 3 is the answer. Minus 13 by 3 is the answer. So this is what the directional derivative for the given problem. So moving on to next problem, 3b. Find divergence of vector f. They are going to provide you vector f. You require to find out divergence of vector f and curl f. So where vector f is defined, they can also define directly as ai plus bj plus ck. Directly they can define vector, or else they can give in this manner, giving grad of phi. So this is nothing but phi. This is nothing but phi. So this is what I have considered. Let given vector f, consider that vector f. Then I have defined phi here as x cube plus y cube plus z cube minus 3xyz. So considering this phi, I will find out grad phi. This problem becomes what? Above problem becomes grad phi. What is grad phi? Grad phi is nothing but just I have told you del phi. Grad phi is nothing but del phi. What is del phi? Del phi by del xi plus del phi by del yj plus del phi by del zk. So now just go with partial derivative, phi with respect to x, phi with respect to y, phi with respect to z. So I got phi with respect to x as 3x square minus 3yz. Phi with respect to y as 3y square minus 3xz. Phi with respect to z as 3z square minus 3xy. So I will name that vector f as f1i plus f2j plus f3k. Then the divergence of vector f is defined by del dot vector f. Del dot vector f, where del is defined as just del by del x I plus del by del yj plus del by del z k. So by just applying dot product with a vector f, I am going to get del f1 by del x plus del f2 by del y plus del f3 by del z. Now again differentiate partially f1 with respect to x. I have defined what is f1, f2, f3, so on. So differentiate f1 with respect to x, I will get 6x, f2 with respect to y, I will get 6y, f3 with respect to z, I will get 6z. So taking out 6 as common, divergence of vector f will be given by 6 times of x plus y plus z. X plus y plus z. Now yet to required curl F. So you should know what is F1, F2, F3. Keeping in your mind what is F1, F2, F3, we will define del cross F. Del cross F is defined as determinant of, it is a determinant of ijk. The first row will be filled with ijk. The second row will be filled with del operator, that is del by del x, del by del y, del by del z. The third row will be filled with vector f called f1, f2, f3. Then after substitution, you should actually substitute here f1 values. So as you know, I told you that keep in your mind. So just it is nothing but just go with expansion of determinant along first row. Along first row, what you are going to get? I into this cross multiplication del by del y of f3 minus del by del z of f2. So that is what I have written here. f3 with respect to y and f2 with respect to z. So I got minus 3x here, minus 3x, minus into minus plus 3x it will be. So it will be minus 3x plus 3x. So therefore it is 0. Vector 0 vector. I will get, since it is a symmetric function, since f1, f2, f3. See here, why I have written summation I will tell you. So the reason behind writing summation 3x square we have here. So the next term of coefficient of j will be 3y square. Next 3z square. Similarly here minus 3yz minus 3xz minus 3xy. It is of the cycle form. It is like a cycle chain. After x, after y, after z. It is of x, y, z. So like this, if you consider x square here, it will be y square, it will be here, it will be z square. Such functions are called symmetric functions. Here y is replaced by z and z is replaced by x in the next term. That's why it is xz. Similarly, x is replaced by y, z is replaced by x. So I will get xy. So that's why we went with summation here. By applying summation here, no need of expanding with j and k. If I expand along only I, I will get the required curl f. So here curl f is an 0 vector. Curl f is an 0 vector. So moving with next problem. Define an irrotational vector. You should define what is irrotational vector. There is a chance of asking another problem called instead of irrotational, solenoidal vector. Find the constants a, b and c such that given vector f is so and so is irrotational. I should show that it is irrotational. So let us go with the definition of irrotation. I have defined here a vector f. Is said to be irrotational. Vector if curl f is equal to 0 vector. If curl f is equal to 0 vector. So since the given vector f is irrotational, we can define, I will consider del cross vector f is equal to 0 vector. So directly I will go with the determinant of ijk, del by del x, del by del y, del by del z. Then I will go with f1, vector f1, f2, f3. So just I have substituted the values of f1, f2, f3. This is what f1, f2, this is f3. So after substitution I am going with expansion. So I times of del, just go with the determinant expansion, del by del y of this term minus del by del z of this minus j, as you know that expansion of determinant, minus j, alternate sign, minus j times of del by del x of bxz square plus cy minus del by del z of this term plus k times of del by del x of this minus del by del y of axy minus z cube equal to 0 vector. So by partial derivative, I got the first term. From the first term, I got c minus 1 I. From second term, I got bz square plus 3z square z j plus 2bx or b times of 2x minus ax k equal to 0. 0 vector means what? 0I plus 0j plus 0k. So as we have equality symbol here, just equate the coefficients of ijk. So I am going to equate the coefficients of ijk. So therefore first term c minus 1 is equal to 0. C minus 1 is equal to 0. Therefore I will get the value as c equal to 1. Similarly b plus 3 equal to 0. I got b value as minus 3. 2b minus a equal to 0. I got a equal to 2b. So from this a is what? Minus 6. A will be equal to minus 6. So similarly, now I am going to substitute all these values a, b, c in vector given vector f. I got the vector f as follows. This is what vector f I have got. So minus 6 x y minus z cube I plus of minus 3x squares plus z j plus of minus 3x z square plus y k. So for the given question, this is the answer. In case if they ask to find a scalar potential called a scalar potential, there is a chance of asking to find scalar potential. That's why I am extending the problem further, as I am explaining only question paper pattern. So in case if they give the question with the scalar potential, you can follow like this. So now consider del phi. Now you can consider del phi is equal to vector f. Then you know the definition of del phi, substitute that definition. You know what is vector f, substitute that. So as we have equality, equate the coefficients of ijk. I got del phi by del x is this, del phi by del y is this, del phi by del z is this. Now integrating with respect to x first term. So integral constant we should write as it is an indefinite integral, right? So we should write integral constant. Here integral constant is f1yz. As we are integrating with respect to x, the integral constant is another two variables called function of yz. Function of yz. So after integrating this term, I got minus 3x square y minus z cube x with respect to x. So I will name this as equation 1. Then if I integrate this term with respect to y, while integrating with respect to y, the integral constant will be f2 times of another two variables called x and z. X, z. So integrating this with respect to y, I got minus 3x square y plus z y. So I will name this as equation 2. So similarly, I will go with integrating with respect to z. I got minus x z cube plus y z plus of f3 xy, f3 of xy. So from 1, 2 and 3, we are going to find out the function of yz, function of xz, function of xy. So function of yz. So leaving from equation 1 and 2, I will observe 2 and 3. I got a function of yz as these two terms, function of yz. So therefore the terms containing yz, alone. So this is what yz. So I wrote f1 of yz as yz. Then f2 of xz from equation 1 and 3, function of xz I should find out. Here I got minus z cube x. Here also I got minus x cube z. So therefore I will write f2 of x comma z as minus x z cube. Finally I require to find out f3 of xy. I will go with equation 1 and 2. So here x y term we have x y term. This is x y term minus 3x square y minus 3x square y. So therefore I will write f3 of xy as minus 3x square y. Now if you substitute all these values f1, f2, f3 in equation 1, 2 and 3, I will get an scalar potential called phi. That is what I have written here, yz minus x z cube minus 3x square y is called scalar potential. So this is another problem to find in case if they ask to find scalar potential. In the previous problem, just they have asked to find the values of a, b, c as it is irrotational. Given vector f is irrotational. After finding a, b, c, if you substitute a in the vector f, it is enough. In case if they ask to find further scalar potential, you should go with this problem. So moving on to choice question or 4a, the question number 4a, find the work done. The set of choices full of integration here, vector integration. Previously we solved all vector differentiation part. Here find the work done. Find the work done in moving a particle in the force field. Vector f is defined along the straight line. Along the straight line by giving 2 points. By giving these two set of points. So consider the given vector f. I have considered the given vector f here. I have considered the vector f. So work done is given by the formula integral over region C f dot dr. Vector f dot dr, where dr is defined as dxi plus dyj plus dzk. What is dr? Dr is defined by dxi plus dyj plus dzk. So now I require to find out the value in terms of t, x, y, z in terms of t. Then we can go with single integral. As we know that the work done is given by single integral value here, integral over region C. I require to find out only for one variable. I can find out for only one variable. As the given problem contains three variables x, y, z, it should be converted to a single variable. By using a distance formula, I have a formula here. This is the formula for distance formula, which is equal to t. I have substituted. So equating that to t, I will get x in terms of t, y in terms of t, z in terms of t. Just you consider this values as x1, y1, z1. Consider this as x2, y2, z2. Just substitute these x1, x2, y1, y2, y3, z1, z2 values in this formula. I am going to get this is the equation. So after substitution, I got x by 2 equal to t, y by 1 equal to t, z by 3 equal to t. So from this, I got x equal to 2t, y equal to t, z equal to 3t by just cross multiplication. Then I will differentiate with respect to t all the variables. So dx by dt, which is nothing but dx is equal to 2 dt. Dx is equal to 2 dt and dy is equal to dt. Dz is equal to 3 dt. Therefore, t ranges from 0 to 1. T ranges from 0 to 1. So now substituting in the standard formula integral over region C f dot dr. Now t ranges from 0 to 1. F is known now. The vector f, just in place of x, y, z, just substitute all the values. As you know what is x, what is y, knowing all those values x, y, z, substitute all those values here. I got vector f as this. I got vector f as this is the equation, vector f dot dr. Dr is nothing but dxy, dyj, all those things, right? Just I have substituted those values. Then as it is a dot product, just I will go with multiplying coefficients of I, j, k. I got after simplification I am telling. This is the simplification. Still I am doing simplification. This is what simplified form. Now I have multiplied the coefficients of I, j, k. So after multiplying coefficients of I, j, k, further simplification I have taken part. I got the integrand as 36t square plus 8t dt. Then integrate this with respect to t. I got 36 times of t cube by 3 plus t into integral of t is t square by 2. Substitute the limits 0 to 1. That is, upper limit is 1. So 36 by 3 plus 8 by 2 minus lower limit. When I substitute both the values as t contains, so therefore it will be 0. Simplifying this, I got the f dot dr value as 60. This is the work done problem. So it is a compulsory question under work done problem. Moving on to next problem. Apply Green's theorem. Apply Green's theorem to evaluate. Apply Green's theorem. You are required to apply Green's theorem to evaluate under the integral sign using the values m dx plus n dy is equal to where C is the boundary region bounded by the line x equal to 0, y equal to 0, x plus y equal to 1. So consider first the given integral. I have written that integral. From this, I told you, right, we can write this as integral form problem as integral over region C m dx plus n dy. So from this, I will identify what is m. I have written that m. I will identify what is n. I have written here. Then I need to find out that integral over. I need to find out integral over region C m dx plus n dy. So using this bounded region. So as the given lines are x equal to 0, this is the line x equal to 0. This will be the line x equal to 0, and y equal to 0 means this is the line, and x plus y equal to 1 means this is the line. So I have considered this value as O A B. So I am going with O A B as like this. So therefore I have written integral OA, integral AB, integral BO, integral BO. Along OA, what is the line equation? The line equation is x equal to 0. Therefore, derivative of that dx will be 0. So, as we are eliminating x part here, the remaining variable is y. So, therefore, the limit is 0 to 1. As the limit is 0 to 1. This is the limit 0 to 1. So, along AB, the line equation is given by y equal to, you can consider x equal to 1 minus y or y equal to 1 minus x. I have considered y equal to 1 minus x. When I consider y equal to 1 minus x, dy will be equal to minus dx. As we are eliminating y, we are left out with the limits called 0 to 1. Next, along the line BO, the line equation is given by y equal to 0. So, therefore, y equal to 0, dy equal to 0, the region, the interval is 1 to 0. The interval of x is 1 to 0. Interval of x is 1 to 0. 1 to 0. So, therefore, substituting all these in this equation, you can name this as equation star, and you can substitute there. So, we will get integral. This is the what after substitution I have got here. Now, after simplification, I have given all the simplification here. You should multiply this value by negative sign. This value is multiplied by negative sign. After simplification, I got this. This is the integration part I have got. Then I am going to integrate each term with respect to those variables. So this is what with respect to integration with respect to y, integration with respect to x, integration with respect to x. After substituting the limits, I got 2 times of 1 minus 0. This is the value after substitution of intervals of x and limits for x. Then after simplification, I got the value as minus pi by 3. Minus pi by 3. So this verifies by Green's theorem. So moving on to next problem. Apply Stokes theorem. So you should apply Stokes theorem. Applying Stokes theorem, you should evaluate double integral over curl f dot n cap ds. So given vector f here, given vector f, taking around the bounded region called x equal to plus or minus a, y equal to 0, y equal to b. So let us go with graph first. So x equal to plus or minus a means minus a plus a. X equal to minus a and plus a. This is what the line. Then y equal to 0 means this is the line, y equal to 0. Then this is the line called y equal to b. So I am taking along a, b, c, d, a, b, c, d. A, B, C, D, a rectangle A, B, C, D, A becomes a rectangle. So here the Stokes theorem is defined as follows. Stokes theorem is given by integral over region C f dot dr. So which is equal to double integral over region S, the surface S, curl f dot ds. I will tell you what is ds. ds is nothing but n cap ds. Vector ds is nothing but n cap ds. So I will find out first vector integral over region C f dot dr. So f is you know what is what a vector f, and also I have defined vector dr, dxi plus dyj plus dzk. Just multiply the coefficients of ijk. I got x square plus y square dx plus of minus 2xy dy. Now I will consider curl f. I need to prove this. So curl f is nothing but del cross vector f. So I will consider the determinant, as there is no term called k here. It is plus 0k. That's why we have denoted by 0 here. Then expanding this, we got along the expansion of determinant, I got this value. How means partial derivative of, you should know that partial derivative properly. Partial derivative of del by del y of 0 is nothing but anything multiplied by 0 is 0, plus minus del by del z. Here we have negative sign. Del by del z, there is no term called z, therefore it is 0. Similarly, leaving second column and first row, I got this into this, therefore it is 0. Minus del by del z of x square plus y square is 0. 0 minus 0. So plus k times of del by del x of minus 2xy is minus 2y. Minus of del by del y of this value is minus plus 2y. So plus into minus, minus 2y. Minus 2y becomes minus 4y k. This is what del cross f we got. So then I require to find out ds. ds is nothing but n cap ds. N cap ds is given by dy dz I plus dz dx j plus dx dy k. Let us find out this. So therefore, as the coefficient of I and j is 0, we are left out with only the coefficient of k. Therefore, double integral over region x equal to, as we have y minus 4y dy dx, minus 4y dy dx, as we are left out with dy and dx. So y ranges from, see the figure, y ranges from 0 to b. Y ranges from what? 0 to b. In multiple integrals I have explained you. So the range of x I need to find. The range of x is what? From minus a to plus a. From minus a to plus a. So therefore, it is integral my x equal to minus a to plus a, y integral y equal to 0 to b, y dy dx. First integrate with respect to y. Integral of y is y square by 2. Limits y equal to 0 to b dx. Substituting the limits, I have got minus 2 b square dx. Integral of dx is with respect to x is x. So after substitution, I got the values as minus 4ab square. Minus 4ab square. So this is what the last question of module 2. So I think you got some idea how to choose the questions from module 2. So in model question paper, they have given vector differentiation separately, vector integration separately. So you can have a option by studying only vector differentiation, or if you are comfortable with vector integration, you can go with vector integration. So I think you're all convinced with my teaching. So if you all like this video, kindly do subscribe my channel and don't forget to press bell button to get new notification. Thank you all.